Hello everyone. This question has been taken from Irodov, Fundamental Equation of Dynamics, question number 73. Question goes like, in the arrangement shown in figure 1.16, the bodies have masses m0, m1, m2, m0, m1, m2. The friction is absent. There is no friction on the surface, in the pulley. The masses of the pulleys and the threads are negligible. The threads mass and the pulley mass is negligible, means it can be considered as 0. Find the acceleration of the body m1. Look into possible cases. So let us solve this question. This is the diagram. We have brought that diagram over here and shown all the tension forces and forces acting on masses m1, m2, m0 here. This m0 is attached to this section of thread, which is at the other end is connected with the axle of this pulley. So tension in and the mass of the thread is negligible. So the tension in the thread throughout will be the same. Same way, mass m1 and m2 is connected with this section of thread, which is passing across the pulley B. And the mass of this thread also is in the question given as negligible, means we can consider as massless. So tension throughout in this thread will be the same. So we have shown that tension as T1. And in this section of thread, we have shown the tension as T. The weight of mass M1 is acting downwards, the gravitational pull, that is M1G. M2G is acting downwards over here, which has been shown here. We have assumed that m0 mass is moving with w0 acceleration. So since m0 is moving with w0 in this direction, the other end of the thread is attached to the pulley B. So pulley B will also come down with an acceleration w0. You can go through the write-up here. For the convenience, we will make the free body diagram of pulley. So on pulley, these forces are acting, these three forces. One is tension force. This tension force due to this section of thread, and below tension force acting in downward direction T1 because of this section of the thread. The pulley is massless, so we can write Newton's law of motion on pulley B, that is T minus 2 into T1 is equal to 0 because mass of the pulley is 0. You are writing mass into acceleration. Mass is 0, the whole thing will be 0. So hence T is equal to 2T1. So this is your number 1 equation. Now we will make the free body diagram of M1. We have made it over here. On M1, tension T1 is acting in the upward direction because of the thread. Weight is acting downwards, that is M1G, because of the gravitational pull. And we are assuming that W1 is the acceleration of mass m1 with respect to ground in the downward direction. So we will apply Newton's law of motion on this and we will reach to this equation, that is m1g minus t1 is equal to m1 into w. So this is your number 2 equation. Third equation we will get from free body diagram of mass m2. On mass m2, T1 is acting upward, weight is acting downward. We have assumed Wt is the acceleration with respect to ground in the downward direction. So we will apply again the Newton's law of motion on this. m2g minus t1 is equal to m2 into w. So this is equation number 3. We know that acceleration of mass m1 with respect to pulley B. It means if you are attaching a frame on pulley B and observing the acceleration of mass m1, so that acceleration we are talking about here. Acceleration of mass m1 with respect to pulley B will be acceleration of mass m1 with respect to ground minus acceleration of pulley B with respect to ground. So acceleration of mass m1 with respect to pulley B we have notated as W1B. W1, we have already said, we have discussed that W1 is the acceleration of mass m1 with respect to ground minus acceleration of pulley B with respect to ground, as we already have assumed that m0 is moving with a W0 acceleration. Pulley B will also go down with W0 acceleration with respect to ground. So we have achieved this, we have got this equation number 4. Same way we will write acceleration of m2 with respect to pulley B is equal to acceleration of mass m2 with respect to the ground minus acceleration of pulley B with respect to ground. W2B we have notated as acceleration of mass m2 with respect to pulley B. W2 we know that acceleration of m2 with respect to ground, and W0 is acceleration of pulley with respect to ground. So this is number 5 equation. Now if you observe the motion of m1 and m2 sitting in a frame attached to B, the pulley B, so what you will see that if m1 is going up, then mass m2 will be going down with the same length. Means if it goes up with distance d, it will also go down, the mass m2 will go down with the distance d, but in the opposite direction. This is going up, this is going down. So it means acceleration of mass m1 with respect to pulley B will be equal to negative of the acceleration of mass m2 with respect to B, pulley B. So W1B plus W2B is equal to 0. And if we add equation 4 and 5, we will get this equation. W1 plus W2 is equal to 2W0. This is equation number 6. So we have 6 equation now. So you can omit for W1. So with the help of all the 6 equations, you can equate. This is your task. You can do this very easily. So W1 will be coming as 4 into M1 M2 plus M0 into M1 minus M2 in bracket. The whole thing in bracket into G divided by 4 M1 M2 plus M0 into M1 plus M2. In the vector form, you can write W1 as a vector. Here G is always acting downward, so you can make G as a vector. So your answer will be this. So hopefully you understand the way to solve it very easily. In case of any doubt anywhere in the steps, please do let me know in the comment box. I will reply on that. Thank you.